Today we're going to start factoring trinomials. You've already learned how to factor out a GCF. We want to make sure that our trinomials are written in standard form and can understand what our A, B, and C are going to be. So standard form would be AX squared. So our A is always with the x squared term, plus BX. Our B is always with the x, and our C is the constant, which is kind of easy to remember because it is C. We're going to go ahead and write out all of the steps that we are going to use with the x method. This x method works for any trinomial where A is equal to 1, greater than 1. It's just imperative that you do the first step in all of them. So step 1, factor out GCF. And I'm going to include if any, because we're not always going to have a GCF, but that we have to look for one first before we can begin the process of the x. Step 2, label A, B, and C. Find out what those coefficients are, or for C, what our constant is. Later on, you will get away from labeling A, B, and C, but some of you guys would like to see that visual, so we will be doing that for today's lesson. Step 3, fill AC in the top of the x and B on the bottom of the x. Step 4, find multiples of AC, the numbers that multiply, other numbers that multiply to become the answer of AC. Side note that if AC is positive, then you add the multiples to the B. And this will all make sense once we actually start the examples, but we're just writing out the steps. If AC is negative, then you subtract the multiples. If I can spell. Okay? Should be pretty easy to remember because if it's positive, you're adding. If it's negative, you're subtracting. Same signs. Okay? Then step 5, check signs in the x. Okay? This is for your side numbers. Reminder that they want to multiply to AAC and add or subtract to B. Step 6, divide side numbers by A, reduce if you can, and then step 7, rewrite as factors. Denominator is the leading coefficient in the binomial. And the numerator is the constant in the binomial. So right now, it looks like it is a long process. These steps will become smaller and or just you will get used to the process of how it works. So what we're going to be doing is starting with a trinomial and breaking it down, okay, into two binomials that if I were to multiply them back together, it would equal the ax squared plus bx plus c. So let's go ahead and just dive into an example so that we can actually see what I'm talking about. If you need to, you guys could always pause the video to write down all those steps. But like I said, the more we do these problems, the more these steps will actually make sense. So let's start with example 1. Okay, let's just make it x squared plus 4x plus 3. Today we are going to be labeling what our a, b, and c are, double checking that it's in standard form. It is x squared, x term, and then our constant. We're good to go. Our a equals 1 because our coefficient in front of this is 1. Our b equals 4, and our constant is 3. Now we will draw our x, so now it'll make all sense where our x numbers will go. A times c goes above, b goes below, like stated in the steps. This is a times c, so let's go ahead and fill that out. That is what step number 3 is saying. So a times c is 3, 1 times 3 is 3, and b is 4. So that's steps 1 through 3 already. Step number 4 is to find the multiples of 3. So we're looking for the numbers that multiply for 3, and we started with a very simple example because the only multiples of 3 are 1 and 3. Okay, so like the side note says, that if our AC is positive, we're looking to add. So if I look, 1 plus 3, there is only one multiple anyways. 1 plus 3 is 4, so 1 and 3 go on the side. Number 5 is asking to check for signs. So this is where I would check. 1 times 3 is positive 3, so we're good to go there. And 1 plus 3 is 4, also good to go there. So step 5 is done. Step number 6 is to take these two side numbers and divide them by our A, which today our A is equal to 1, and if we divide anything by 1, it does not change the value. But we need to make sure we understand this so that when we get into where A is greater than 1 in a couple of lessons, you won't forget this step. So we will do 1 divide by 1, which we know reduces to just 1. And we will do 3 divide by 1, which reduces to 3. So we have both of our factors, we just need to rewrite them into binomials. So this is step number 7. With this and this visual representation, we can see that our denominator is 1. We know that if it's just an integer, it is automatically over 1. This is going to be our leading coefficient. Instead of writing 1x, we know we can just write x. This is a positive 1, so we will write plus 1. Parentheses. The second binomial, same thing. The denominator is 1, so it's just x. And our numerator is 3, so we would just write plus 3. And there is your first factored trinomial. If you want to, you can always double check your answer by rewriting this in the area model to make sure that if you multiply them back together, you get what you started with. I'm going to show this on the first 2 examples just to show you guys if you are unsure with your answers, you could always check them. So we know that x times x is x squared. X times 1 is 1x, or just x. 3 times x is 3x. And 3 times 1 is 3. Our first term doesn't change, so it stays x squared. Combine at the diagonal. 3x plus x, because those are like terms, would be positive 4x, and our constant plus 3. So if I look, they multiply to be out to become what we started with. So I know that this is my answer for factoring that trinomial. Okay? So let's do another example together. Example 2. Let's say that it's x squared minus 3x minus 10. Step number 1, look to see if there's a GCF. It's 1, negative 3, and negative 10. There's definitely no GCF because one of my coefficients is 1. So I label my A, B, and C. A equals 1, B equals negative 3, and C equals negative 10. We would draw our x. Going to step 3, A times C, B below. A times C, 1 times negative 10 is negative 10. B is negative 3. Moving on to step number 4, we look at our AC and write multiples of 10. I wouldn't worry that it's a negative, besides that I know that I'm going to subtract the multiples to 3. So let's go ahead and write 10. If you want to, you could write negative 10, but don't worry about the negatives and or positives when you are setting up your multiples. I'm just doing 1 times 10, which is 10, and 2 times 5, which is 10. Those are the only multiples, so we have a little bit more options than we did on example 1. So we're looking to subtract these multiples to 3. So if I subtract 10 and 1, it's 9, definitely not 3, so that's not our option. But if I look at 5 and 2, if I subtract those, that is a difference of 3. So I'm going to pick 2 and 5. It does not matter which order you put these in, because order of multiplication doesn't matter. So last step for the x, to make sure we're correct, is to check our signs. So I know that one of these have to be negative, because if I do 2 times 5, it's positive 10, not negative 10. So this is where I want to look at to see which one needs to be negative when I'm subtracting. This is a negative 3. So I ask myself, does 5 minus 2 equal negative 3, or does 2 minus 5 equal negative 3? The negative needs to be with the bigger number because it is negative 3. So double check the x. This is still step number 5 to be sure that we're good. 2 times negative 5 is negative 10. Good to go. And 2 minus 5 is negative 3. Go ahead and take your side numbers and divide them by your a. So 2 over 1, which equals 2. And negative 5 over 1, which equals negative 5. This time, in the binomial, this one will have a plus sign because it's positive, but this one will have a negative because it's a negative or a minus sign. So when we rewrite this binomial, my leading coefficient is 1 again, so just x plus 2. This denominator is also 1, so it becomes 1x or x minus 5. Again, I told you guys I would show you guys could double check your answer on the first 2 examples. So let's go ahead and double check that now. Set up the area model. We have x plus 2 times x and negative 5. X times x is x squared. X times 2 is 2x. X times negative 5, which is negative 5x. And negative 5 times 2 is negative 10. Simplifying our answer, we have x squared. Negative 5 plus 2x is negative 3x minus 10. Compare what we started with. We're good to go. This is my answer factored. So let me give you guys one to practice. Let's say it's x squared plus 9x plus 18. I'll help you with the first step, which is labeling A equals 1, B equals 9, and C equals 18. Set up your X, A times C above, B below. Go ahead and pause it and try to work it out. All right, so you should have done 1 times 18, which is 18, B below, which is 9. After we have our top and bottom filled, we write our multiples of the top number. So multiples of 18 are 1 and 18, 2 and 9, 3 and 6. That's a complete list. It is positive 18, so we're looking to add to 9. The two that add to 9 are 3 and 6. Again, it doesn't matter the order you place them. So 3 and 6. Double check our signs. 3 times 6 is 18. 3 plus 6 is 9. Good to go. Take the side numbers, divide them by 1, which you guys should start to realize the pattern. It doesn't matter when we divide by 1 on these. And our binomials just become x plus or minus this number, x plus or minus this number. They're both positives, so it should be x plus 3 and x plus 6. If you need, go ahead and multiply those out to make sure that it equals x squared plus 9x plus 18. This is your final answer. Okay? And I'm going to go ahead and give you 2 more this time to go ahead and try, and then we will review them. So problem number 2, x squared plus 6x minus 7. And number 3, x squared minus 10x plus 24. Go ahead and pause and try them out. On number 2, should have known that A equals 1, B equals 6, and C equals negative 7. If you're getting used to this, then you don't have to do that part. It's just there to help those that need it. Then we would draw our X, A times C, B below. A times C is negative 7, B is positive 6. Need multiples of AC, which is 7. Again, you could put the negative, but don't worry about the signs. Only multiples of 7 should have been really easy. Should have been 1 and 7. It is negative, so we're looking to subtract. And if I do 7 minus 1, it's 6. I'm good to go. So 1 and 7. Checking the signs. 1 times 7 is positive 7. One of them needs to be negative. It's a positive 6. So I know my bigger number needs to be positive, making it negative 1. Take my 2 side numbers, negative 1, and divide them by 1, which still equals negative 1. And the other side number, 7 divided by 1, which still equals 7. This binomial will have a subtraction. This binomial will have addition because this one's negative, this one is positive. Final answer for number 2 should be x minus 1 times x plus 7. Again, you can check it if you need to. This is our final answer, though. If you need to or want to, you can pause the video again and go ahead and work on number 3 if you want to correct anything or fix anything from what we've just gone over. Okay, on number 3, again, if you need to label, A equals 1, B equals negative 10, and C equals 24. Make our X, A times C above, B below. 1 times 24 is 24. B is negative 10. we need multiples of 24. So for 24, there are a little bit more. We have 1 times 24. We have 2 times 12, 3 times 8, and 4 times 6. It is positive, so we're looking to add to 10. These multiples add up to 25, definitely not it. Add up to 14, not it. Add up to 11, not it. 4 plus 6, there we go. It's 10. Got to check our signs. 4 times 6 is positive 24, but 4 plus 6 is positive 10. So in this case, since our AC is positive, we need them to both be the same sign. So we're going to make them both negative, because negative 4 times negative 6 is positive 24, and negative 4 minus 6 is negative 10. So now our x works, making sure that our signs are correct. Take our two side numbers, divide them by 1, still equals negative 4. Negative 6 divided by 1 is still negative 6. They're both negatives, so in my binomials, they will be separated by a minus sign. Final answer is x minus 4 times x minus 6. If you want to check, you are more than welcome. Now you guys can go and practice on the practice problems provided.